All right, in this video we're starting 3.3, which is talking more about functions. We're going to start with the idea of even and odd functions. So we've got the book definition here for an even function. And it says that for every x in the domain, negative x is also in the domain. So we're just making sure that everything exists. You don't have to worry about that part too much. And we need to know that f of negative x is equal to f of x. So when we plug in a negative x, we get the same value back as we did for f of x. All right, so that's a pretty simple definition, but what does it mean? Well, we've actually seen this before. So this first part where x and negative x are in the domain, that means that we have a point xy, and we know that negative x is also in the domain, and what this tells us right here is that when we plug in negative x, we get the same y back again. So if y is equal to f of x, we get the same y back again. So that means when we plug in negative x, we get negative xy. So we've seen this before. If xy exists, then we know negative xy is also on the graph. So replace x with negative x, and that is y-axis symmetry. Okay, so when we replace x with negative x, we get the same y value. That's y-axis symmetry. So how does this work in terms of function notation? Well, let's look at a function. Let's say we have 2x squared plus 3. So we want to see what happens when we do f of negative x. So remember when we talked about this in the last section, that means that we replace x with negative x. So anywhere that there was an x is now going to become negative x. So we get 2 times negative x squared plus 3. And just like before, negative x squared is the same as positive x squared. So when we simplify, we get back to what we started with. And so we know that this is an even function. Okay, so when we plug in negative x, we get back to what we started with, and that makes it an even function, which means we have y-axis symmetry. All right, so looking at odd functions, for every x in the domain, negative x is also in the domain. So again, we're making sure everything exists. And this time when we put in negative x, we get negative y, negative function value or negative y. So that means that for every xy, we know that when we plug in negative x, we get negative y. And we've seen this before as well. This was symmetry to the origin. Okay, so odd function is the same as symmetry to the origin. Although if you remember when we looked at symmetry before, not everything that we looked at was a function. So you can't go the other way as well. Not everything that's symmetric to the origin is an odd function because not all of them are functions. But if it's odd, then it's definitely symmetric to the origin. So let's look at how this one works. Let's say we have f of x is equal to x cubed plus 2x. And again, we're going to look at f of negative x. So we plug in negative x and we see what happens. So we're going to have negative x cubed plus 2 times negative x, and we need to simplify this and see what happens. So negative x cubed, again, remember from last time, that's negative x cubed, and then this is going to give us minus 2x. So is that the same as what we started with? No, it's not. So it's not even, but is it negative of what we started with? Well, let's try to factor a negative out and see what happens. Remember, if we factor a negative out, that's going to change all of the signs. Yes, that is what we started with. So we have negative of what we started with, which is what we're looking for right here, negative of what we started with. And so this is an odd function.